All right, in this section, we're going to talk about theoretical probability, something you've probably discussed in other math classes. So hopefully this will mostly be a review. So there's the definition of theoretical probability. We're going to practice calculating it for these examples below. So example 1 says we're going to calculate the probability of event A. We're going to calculate the probability of event A union event B, A intersection B, and then the probability of the complement of event A for the following situation. You roll a number cube. Event A is rolling a prime number. Event B is rolling an even number. So the first thing that I want you to do is I want you to draw a Venn diagram. So event A and event B. And they are going to intersect. I'm going to go ahead and draw them in a big rectangle. That's a universal set. We're actually going to call it S for sample space. In probability, we use the term sample space instead of universal set. Tells us the sample space or the universal set is 1, 2, 3, 4, 5, 6. So A is rolling a prime number from 1 through 6. So that's just numbers 2, 3, and 5 in circle A, because those are the prime numbers. Event B is rolling an even number, so that would be 2, 4, and 6. Well, notice there's a little bit of overlap, so I'm going to erase 2 and put it in the intersection spot. And then what's left over here? 1 has not been used, and that's it. All right, so now we can answer the questions. The first question wants to know, okay, what's the probability of A happening? So look up here at the formula. The formula is the number of outcomes in the event. So A has 3 elements in its set, or 3 outcomes, divided by the total number of outcomes in the sample space. Well, how many numbers are there in the sample space? There's 1, 2, 3, 4, 5, 6. So there's a 3 out of 6 chance, reducing to 1/2. So the probability of A is 1/2. The next one wants to know what's the probability of A union B. So let's think about it. Where A union B means all of the numbers that are in A or B, or in other words, just all of the numbers combined. So that's 3, 5, 2, 4, and 6. All of those numbers are either in A or B. So that's a total of 5 numbers divided by 6 total possible outcomes. So there's still 6 numbers you could roll in that dice, but there's a 5 out of 6 chance that one of those numbers is either going to be in A or B. The next one wants to know the intersection of sets A and B. So there's only one number that's in both A and B, and that's 2. And there's still 6 possible outcomes on the die. So there's a 1 out of 6 chance. Go ahead and circle all these answers. And then our last one is the complement. What's the probability of the complement of event A? So basically it wants to know what numbers are not in A, or how many numbers really are not in A. Well, that's 1 is not in set A, 4 and 6 are not in set A. So there's 3 numbers on a 6-sided die. So there's a 3 out of 6, which reduces to a 1/2 chance that you're going to get something that's a complement of event A. All right, in this last example, take some time reading this last example. We're not going to draw a Venn diagram on this one, but you can. Your grocery basket contains 1 bag of each of the following items. You've got oranges, apples, green grapes, green broccoli, white cauliflower, orange carrots, and green spinach. You're getting ready to transfer your items from your cart to the conveyor belt for checkout. Event A is picking a bag containing a vegetable first. So the first thing we might want to do is write how many elements are in set A. So set A deals with vegetables. So how many vegetables do we have here? We got broccoli, cauliflower, carrots, spinach. So there's 4 elements in set A. In set B, it's picking a green food first. So the number of elements in set B, we've got green apples, so that's an element in set B. We got green grapes, that's 2, broccoli, 3, spinach, 4. So I see 4 elements in set B. It says all bags have an equal chance of being picked first. That's what makes this theoretical probability. The universal set will be defined as all of the items together. So all together, again, we have 7 items. So the first question, and that's important too, so the number of elements in set U is 7. That's basically going to be the bottom number of all of our theoretical probability fractions. So we want to know the probability of event A union event B. Remember, this is all the elements that are in A or B, or in other words, everything in A, everything in B. So some of you may be thinking, okay, well, there's 8 total elements in A and B, so it's 8 out of 7. Of course, that doesn't make any sense. But remember, there's some overlap here. So what we might want to do is we might actually want to write out, okay, what are those 4 elements in set A? So the vegetables in set A are going to be broccoli, cauliflower, carrot, and spinach. So that's set A. Set B, again, has 4 elements as well. Those are the green food. So it's green grapes, green apples, green broccoli. There's some overlap there. They both have broccoli. And green spinach. There's some more overlap. So in other words, we don't want to count those terms twice because that's where these 2 sets intersect. So the probability of A union B is all of the items in both of those sets without repeating yourself. So there's 6 total items up there without repeating ourselves, because remember, spinach shows up here and broccoli shows up here in both places. So there's 6 total items. So a 6 out of 7 chance of getting something in set A or set B. And this last one wants to know the intersection. This one a little bit easier, so we've already done this. We know that they overlap with 2 items. They both have broccoli, they both have spinach. So there's a 2 out of 7 chance. We put something on the conveyor belt that's from set A or set B. And set B, I'm sorry. It's in set A and set B. And then finally, we want to know what's the probability that we pull an item that's a complement to set A, or in other words, not in set A. Well, if there's 7 total items and there's 4 items in set A, that means there's 3 items that are not in set A. So there's a 3 out of 7 chance of pulling something that's not in set A. So I encourage you, try this last one, pause the video, try to get the answers to your turn number 3. All right, so here are the answers. Remember, you want to reduce all fractions for full credit.